Imagine walking into a luxury fashion boutique, running your hand across an incredibly soft piece of fabric, watching the light reflect off its silky surface, and then discovering that, just a few weeks earlier, it was garbage. Not recycled plastic, not cotton, not silk. Orange peels. The same orange peels most of us throw away without giving them a second thought. Every year, Italy produces around 700 tons of orange waste after making juice. For decades, that waste had very little value. It was expensive to dispose of, difficult to store, and for juice producers, it was simply another industrial problem. But hidden inside every discarded orange peel was something extraordinary. A natural fiber so valuable that it could eventually become fabric for some of the world's most prestigious fashion brands. Today, we're taking you inside a factory that has achieved what sounds almost impossible: turning fruit waste into luxury fashion. This is the incredible journey of how discarded oranges become one of the most fascinating textiles on Earth. At first glance, the factory doesn't look anything like a luxury fashion brand. There are no elegant showrooms, no designer sketches, no expensive dresses hanging on display. Instead, truck after truck arrives carrying what appears to be nothing more than wet organic waste. Orange peels, seeds, pulp, everything left behind after the juice has been extracted. To almost everyone else, this is trash. But here, it's the beginning of an entirely different story. Workers don't see waste, they see raw material, potential. And hidden inside every load is the ingredient that makes this entire process possible: cellulose, the same natural building block found in trees, cotton, and countless plants across the world. The remarkable difference is where this cellulose comes from. Not forests, not cotton fields, but discarded oranges. Every shipment is carefully weighed before entering production. Thousands of kilograms arrive every day. Each batch receives its own identification number. Its origin is recorded, its weight documented, its quality inspected. This isn't just good organization, it's complete traceability. Years later, a finished roll of fabric can still be traced back to the exact oranges that produced it. That level of control is essential when supplying luxury fashion brands. Every meter of fabric must have a documented history, because in high-end fashion, quality begins long before the fabric ever reaches a designer. But there's one major problem. Fresh orange waste is incredibly difficult to work with. Around 70% of its weight is simply water. Imagine trying to manufacture fabric from something that's mostly moisture. It's almost impossible. Before anything valuable can be extracted, the factory has to completely transform the material. The mixture of peels, pulp, and seeds is first unloaded into massive industrial grinders. Powerful rotating blades reduce everything into a uniform paste. The goal isn't to destroy the material. It's to make every piece the same size. Why? Because consistency is everything. If some pieces are large while others are tiny, the next stages become far less efficient. A perfectly uniform paste dries more evenly, reacts more consistently, and ultimately produces higher quality fibers. Sometimes the smallest details determine the success of an entire industrial process. From there, the orange paste begins one of its most important transformations. Drying. Gigantic rotating drums slowly tumble the material while streams of hot air pass through the system. Almost immediately, steam begins escaping. At first, the paste is bright orange, heavy, sticky, almost impossible to handle. But hour by hour, something remarkable happens. As moisture leaves the material, its appearance begins changing. The vibrant orange slowly fades into a darker, matte color. The texture changes completely. The sticky paste becomes lighter, drier, more stable. By the time it leaves the dryers, its moisture content has fallen from around 70% to just 10%. That single change completely transforms the material. It's now almost 10 times lighter than when it first arrived. easier to transport, easier to store, and finally ready for the next stage. But before the factory moves forward, one last measurement is taken. Specialized sensors verify the exact remaining moisture. Just a small deviation could affect everything that follows. Too much water, and the chemistry won't work properly. Too little, and valuable cellulose could be damaged. In this factory, even a single percentage point matters. But here's something even more fascinating. The factory doesn't simply throw away everything that evaporates during drying. Even the drying process creates another valuable product. As the orange waste releases moisture, it also releases tiny amounts of essential orange oil. Instead of allowing those aromatic compounds to disappear into the atmosphere, the factory captures them. The oil is collected, purified, and sold separately for use in fragrances, cosmetics, cleaning products, and food flavorings. Think about that for a moment. The factory is already making money before it has even started producing fabric. It's a perfect example of modern circular manufacturing. Almost nothing is wasted. Every possible resource is recovered. Every byproduct becomes another product. What began as industrial waste is already generating multiple revenue streams. And yet, the most valuable transformation hasn't even started. Because despite all these changes, this material is still unmistakably orange waste. It still smells like oranges. It still looks like oranges. It still is oranges. But that identity is about to disappear forever. In the next stage, chemistry will begin stripping away everything that makes an orange, until only one extraordinary material remains: pure cellulose. The same substance that will eventually become a fabric worthy of the world's most exclusive fashion houses. By the time the drying process is complete, the orange waste is almost unrecognizable. It's lighter, more stable, and carefully sealed to prevent it from absorbing moisture again. But despite everything that's happened so far, the most valuable part of the orange is still trapped inside. Hidden within this dry, brittle material are microscopic cellulose fibers. The problem is, they are buried beneath layers of natural sugars, pectins, plant oils, pigments, and dozens of other organic compounds. If the factory wants to create luxury fabric, every one of those substances has to disappear without damaging the cellulose itself. That challenge can't be solved with sharper blades or hotter ovens. It requires chemistry. Behind heavy industrial doors lies the most controlled area of the factory, the extraction room. This is where the orange finally loses its identity. Massive stainless steel reactors stand silently waiting. Each one is designed to do something that sounds almost impossible: take apart an orange at the molecular level. The dried orange material is carefully fed into one of these sealed vessels. Then, the first chemical solution is introduced, an alkaline mixture specifically designed to dissolve everything surrounding the cellulose fibers. As the reactor closes, the temperature slowly rises. Pressure begins to build. Inside, an invisible transformation is taking place. Sugars start breaking down. Natural oils separate from the solid material. Sticky pectins dissolve into the liquid. Little by little, everything that once made this material look, smell, and behave like an orange begins to disappear. It's almost as if the factory is peeling away the fruit, one molecule at a time. Hours later, the reactor is opened. What comes out hardly resembles what went in. A dark brown liquid drains away, carrying dissolved sugars, pigments, oils, and countless other compounds extracted from the orange waste. This liquid may look like useless sludge, but it represents everything the factory no longer needs. What remains inside the reactor is something completely different, a pale solid that's becoming richer in cellulose with every passing stage. But it's still not pure enough, not even close. The solid material now enters a series of intensive washing cycles. Fresh water flows through the cellulose again and again. Each wash removes traces of the previous chemical treatment. Each rinse carries away microscopic impurities that could interfere with the next stage. The process is surprisingly. At first, the water leaving the reactor is deep brown, then amber, then pale yellow. With every cycle, it becomes clearer, until eventually it runs almost transparent. That's one of the simplest indicators the technicians have. The clearer the water becomes, the purer the cellulose inside. It's a slow process. But precision matters far more than speed. Once the alkaline treatment is complete, the factory performs a second purification step. This time, a different chemical solution targets the tiny impurities that survived the first extraction. Compounds that are almost impossible to remove mechanically simply dissolve away. Again, the cellulose is washed. Again, the remaining contaminants disappear. Every cycle brings the material one step closer to becoming textile-grade cellulose. Because luxury fabric doesn't tolerate imperfections, even microscopic contamination can weaken the fibers, affect the spinning process, or create visible defects in the finished fabric. At this stage, perfection isn't a goal, it's a requirement. Once the chemical treatments are complete, the material moves into powerful industrial presses. Thousands of kilograms of force squeeze out the remaining water. The transformation is astonishing. Gone is the sticky orange paste that entered the factory. Gone are the bright colors. Gone is the citrus aroma. What's left is a dense, soft, almost snow-white material. If someone placed it in front of you, you'd never guess it once came from discarded orange peels. It doesn't smell like fruit. It doesn't feel like fruit. It doesn't even look organic anymore. What remains is almost pure cellulose, the invisible structural framework that existed inside every orange all along. But appearances can be deceiving. Looking pure isn't enough. The factory has to prove it. Small samples from every production batch are sent directly to the laboratory. Here, scientists analyze the cellulose using highly specialized equipment. They measure its composition, its moisture content, its fiber quality, and most importantly, its purity. Only one specific form of cellulose can eventually become textile fiber. Known as alpha cellulose, it's the strongest and most stable fraction found inside plant material. If too many unwanted compounds remain, the entire batch could fail. And thousands of kilograms of material would never make it to the spinning machines. That's why every single lot must pass strict laboratory testing before moving forward. The numbers matter. To qualify for textile production, the cellulose must reach an exceptionally high level of purity. Anything less, and the fibers may break during manufacturing. The fabric could lose its softness, its strength, or its luxurious appearance. In high-end textiles, tiny imperfections become expensive problems. That's why quality control isn't just another department. It's part of every step. From the moment the orange waste enters the factory until the finished fabric reaches a designer's hands. Once laboratory approval is granted, the cellulose undergoes one final preparation. Its molecular structure is carefully conditioned for what comes next. The remaining chemicals are completely neutralized. The pH is brought back to a balanced level. The material is gently dried under tightly controlled temperatures. Too much heat could permanently damage the cellulose chains. Too little and excess moisture would interfere with the next process. Every variable is monitored continuously. Temperature, humidity, time. Nothing is left to chance. Finally, the cellulose is cut into smaller, uniform fragments. At first glance, it seems like a simple mechanical step, but it plays a crucial role. Smaller pieces dissolve more evenly later on, which means smoother fibers, fewer defects, and stronger yarn. Sometimes, the quality of an expensive luxury fabric depends on details almost impossible to see with the naked eye. Now, for the first time since arriving at the factory, the orange has completely disappeared. No peel, no pulp, no seeds, no color, no aroma, no trace of the fruit itself. Only pure white cellulose remains. It may not look impressive, but this ordinary-looking material is about to undergo its most extraordinary transformation yet, because in the next room, a remarkable solvent is waiting. One capable of turning this solid plant fiber into something that flows like liquid silk. And that's where the real magic begins. By now, the transformation is already astonishing. A truckload of discarded orange waste has become something that looks more like purified cotton than fruit. No color, no citrus aroma, no visible trace of the oranges that arrived at the factory only days earlier. But despite its appearance, this material still has one major problem. It's solid. And solid cellulose cannot be spun into thread. Before it can become fabric, it first has to become something completely different. A thick, perfectly uniform liquid, one that can be stretched into fibers thinner than a human hair. For decades, that was one of the biggest challenges in textile manufacturing. Cellulose is incredibly strong. Its molecules cling tightly together through countless microscopic hydrogen bonds. That's why trees can stand for centuries, why cotton is so durable, and why cellulose refuses to dissolve in ordinary liquids. Water won't do it, alcohol won't do it, even most industrial chemicals fail. Finding a way to dissolve cellulose without destroying it became one of the textile industry's greatest scientific breakthroughs, and that breakthrough is waiting just beyond these doors. Welcome to the lyocell production room. Unlike many traditional textile processes, this one relies on a solvent that behaves very differently. Its name is N-methylmorpholine N-oxide, or simply NMMO. It may sound intimidating, but its job is surprisingly simple. Instead of breaking cellulose apart, it gently separates the microscopic bonds holding the fibers together. The cellulose keeps its molecular structure. It simply changes its physical form. That single difference is what makes the lyocell process so revolutionary. Older methods often relied on aggressive chemicals that produced hazardous byproducts. Here, the goal is completely different. Preserve the cellulose, recover almost everything used during production, and generate as little waste as possible. The purified cellulose is carefully added to another stainless steel reactor. Then, the NMMO solvent is introduced. Nothing dramatic happens at first. The mixture appears almost unchanged. But as the temperature slowly climbs to around 90 degrees Celsius, something remarkable begins. Little by little, the solid cellulose starts disappearing. Not because it's breaking apart, but because it's dissolving. Inside the reactor, millions upon millions of cellulose molecules are gradually separating from one another. The rigid white fibers slowly transform into an amber-colored liquid. Its consistency resembles warm honey, smooth, glossy, perfectly uniform. It's hard to believe that only a short time ago, this same material was part of an orange peel lying in a pile of industrial waste. Creating this solution requires extraordinary precision. Too much heat, and the cellulose can begin degrading. Too little, and it won't dissolve completely. Even the mixing speed must remain carefully controlled. Every sensor inside the reactor continuously monitors temperature, pressure, viscosity, and concentration. Because once this solution moves forward, there is no easy way to correct mistakes. Luxury textiles demand absolute consistency. Every batch must behave exactly like the last. Eventually, the cellulose is fully dissolved. The result is known as a spinning dope. It may look like an ordinary industrial liquid, but it's actually the future fabric itself. Every single thread that will eventually become luxurious clothing is already hidden inside this viscous solution. The challenge now is turning that liquid back into solid fibers without losing its extraordinary smoothness. Before that can happen, one final obstacle remains: purity. Even after laboratory testing, microscopic particles can still find their way into the solution. Tiny contaminants, undissolved fragments, almost invisible impurities. Normally, they wouldn't matter, but the next machine contains hundreds of microscopic openings, some barely wider than a human hair. One tiny particle could block them completely. That's why the spinning solution passes through extremely high-pressure filtration systems. Layer after layer, the filters remove anything that should not be there. The result is an almost flawless liquid, smooth enough to pass through openings so small they are nearly impossible to see. From the filtration system, heated pipelines transport the solution toward one of the most fascinating machines in the factory, the spinneret. At first glance, it does not look particularly impressive, just a polished metal plate. But its surface contains hundreds, sometimes thousands, of microscopic holes. Each one acts like an artificial version of a spider's silk gland, except instead of producing silk proteins, it produces continuous filaments of orange cellulose. The pressure slowly pushes the liquid through every tiny opening. As it emerges, something incredible begins to happen. The liquid does not immediately become fiber. First, it passes through a very short air gap, only a few centimeters long. It might seem insignificant, but this tiny space determines much of the final fiber's strength. As gravity pulls the liquid downward, the cellulose molecules naturally begin aligning in the same direction. Think of it like combing thousands of microscopic strands until they all point the same way. That alignment is what gives the future fabric its durability. Without it, the fibers would be weak, irregular, and unsuitable for luxury textiles. Sometimes, the difference between ordinary fabric and premium fabric is measured in just a few centimeters. Moments later, the newly formed filaments enter a water bath, and this is where the real transformation occurs. The water gently removes the NMMO solvent from the cellulose. As the solvent leaves, the cellulose molecules reconnect. Almost instantly, the liquid solidifies. What entered the bath as a flowing solution emerges as an incredibly fine, continuous filament. This is the exact moment. Orange cellulose becomes textile fiber for the very first time. Hundreds of shimmering strands float gracefully through the water. They almost resemble natural silk. Smooth, flexible, almost translucent under the factory lights. It is difficult to imagine these delicate fibers once existed inside discarded orange peels. But perhaps the most remarkable part of the entire process is what happens to the solvent. Instead of being discarded, the NMMO dissolved in the water is carefully separated, purified, and returned directly to production. Nearly 99% of it is recovered and reused. Again and again, batch after batch. This closed-loop system is one of the defining features of the lyocell process. It dramatically reduces waste, lowers chemical consumption, and makes the manufacturing process far more sustainable than many conventional textile methods. In this factory, even the chemicals are given a second life. Kilometer after kilometer of continuous filament begins winding onto enormous spinning reels. Each spool fills with thread so fine, so smooth, and so consistent that it's almost impossible to believe its origin. Just days ago, it was agricultural waste. Now, it's a material worthy of some of the most demanding textile manufacturers in the world. But despite its incredible appearance, the journey isn't over. Not even close, because these endless filaments still don't behave like traditional textile fibers. They're too straight, too smooth, too perfect. Before they can become yarn, they must first be given something that nature perfected millions of years ago: texture, flexibility, and movement. Only then will orange cellulose truly begin to feel like luxury fabric. The moment the cellulose leaves the lyocell process, it has officially become fiber. Long, smooth, Continuous strands of orange cellulose stretch across the factory, winding onto enormous reels. From a scientific perspective, the impossible has already happened. A discarded orange peel has become a textile filament, but from a fashion perspective, it's still unusable. If you tried weaving these perfectly straight filaments into fabric, the result would feel lifeless. Flat, too stiff, too uniform. Luxury fabrics don't just look beautiful. They move, they drape, they flow naturally with every movement of the body. Creating that sensation requires one final transformation. The fibers have to behave less like an industrial material and more like something created by nature itself. The first stop is the crimping machine. At first glance, the process seems surprisingly simple. Instead of keeping every filament perfectly straight, the machine introduces thousands of tiny waves along each strand, almost invisible to the naked eye. Yet these microscopic bends completely change how the fiber behaves. Imagine comparing perfectly straight hair to naturally curly hair. The material is still the same, but its movement, its volume, and the way it interacts with light become completely different. Exactly the same principle applies here. Without crimping, the fibers would slide past one another too easily. The yarn would lack elasticity. The finished fabric would feel flat and lifeless. Those tiny waves create microscopic pockets of air inside the future textile. And that's what gives luxury fabrics their soft, full-bodied feel. It's one of those manufacturing steps most people never notice, yet they immediately notice its absence. Once the fibers have been crimped, they receive another invisible treatment. A biodegradable lubricant is applied across their surface. At first, that might sound unnecessary. After all, the fibers already look perfectly smooth, but appearances can be deceiving. The next machines will pull, stretch, comb, and twist millions of individual fibers at incredible speeds. Without lubrication, friction would increase dramatically. The fibers would snap, static electricity would build up. Production would slow to a crawl. Instead, a microscopic protective coating allows every strand to glide effortlessly through the machinery. It's temporary, almost invisible, but absolutely essential. Sometimes, the smallest amount of material protects kilometers of future fabric. The endless filaments now reach one of the few places where they are intentionally apart. Rotating blades slice them into thousands of short fibers, each one measured to an exact length. That length is not chosen at random. It determines how the finished yarn will behave. Longer fibers generally create stronger, smoother, finer yarns. Shorter fibers produce different textures and different performance characteristics. For luxury fashion, consistency is everything. Every fiber in the batch must be almost identical. Only then can the yarn achieve the uniform appearance demanded by premium brands. Looking down the production line, the transformation is extraordinary. Instead of endless, transparent filaments, there are now millions of delicate white fibers, soft, lightweight, and almost weightless as they move through the air. If sunlight catches them just right, they seem to glow. It is difficult to believe these fragile strands once formed part of an orange peel. Now comes one of the oldest processes in textile manufacturing, carding. Although today's machines are vastly more advanced, the basic idea has remained almost unchanged for centuries. Thousands of fine metallic teeth gently comb through the fibers, again and again and again. Wannegerith Reden Thurshafe. The goal is not simply to straighten them, it is to organize complete chaos. Every loose strand becomes aligned in roughly the same direction. Small knots disappear, tiny clumps are broken apart, remaining impurities are removed. Gradually, millions of random fibers begin behaving like one continuous material. Watching the process is almost hypnotic. The tangled mass slowly transforms into an incredibly thin web, so light, so delicate, that it almost appears to float through the factory. Workers often describe it as looking more like mist than fabric. But this fragile veil represents perfect organization at a microscopic level. That web cannot enter the spinning machines yet. It is still too wide, too delicate, and impossible to control. So another machine gently gathers it together. Slowly, the thin sheet collapses into a long, soft rope known as a sliver. Unlike yarn, the sliver contains almost no twist. The fibers simply lie alongside one another, held together only by their own alignment. It may not look impressive, but this is exactly what the spinning machines need. The raw ingredients have finally been prepared. The next stage will give them strength. Before production continues, quality control takes over once again. Experienced technicians carefully inspect the sliver under bright lighting. They are searching for anything unusual. A dense section, a thin spot, an unexpected clump. Even tiny irregularities can multiply throughout the spinning process. One weak section today could become hundreds of meters of defective yarn tomorrow. That is why inspections happen continuously, not just at the beginning or the end, but throughout the entire manufacturing process. Luxury textiles are not built by fixing mistakes later. They are built by preventing mistakes from happening in the first place. The laboratory also performs another series of measurements. One of the most important is fiber fineness. In luxury textiles, finer fibers usually create softer, lighter, and more elegant fabrics. The very finest orange fibers are reserved for premium collections, those destined for haute couture, designer garments, and limited edition fabrics where every detail matters. Other batches may eventually become scarves, blouses, luxury linings, or premium fashion accessories. Even before a single thread has been spun, the factory already knows where the material is likely to end up. Everything now leads toward one final destination, the spinning room. This is where millions of carefully prepared fibers will finally become something every textile mill recognizes: yarn. For the first time since entering the factory, the material is only moments away from taking the form that designers, weavers, and fashion houses have worked with for centuries. The transformation from agricultural waste is almost complete. Only one final mechanical process remains. And it is the one that will determine whether this extraordinary material is worthy of becoming luxury fabric worn on runways in Milan, Paris, and New York. Everything that has happened inside the factory has been leading to this moment. The orange waste has been cleaned, purified, dissolved, turned into delicate fibers, combed, aligned, and carefully inspected. But despite all that work, it still is not yarn. Without yarn, there can be no fabric, no clothing, no luxury fashion. The next room is where millions of individual fibers finally become one continuous thread. And although the machines look incredibly modern, the principle behind them has remained almost unchanged for centuries. Strength comes from twist. The first stage is called drawing. Several slivers arrive simultaneously from the previous machines. Each one contains thousands of loose fibers lying side by side. On their own, none of them are perfectly uniform. One may be slightly thicker, another slightly thinner. Tiny variations are completely normal. But luxury textile production does not accept almost uniform. It demands consistency from beginning to end. That is exactly what drawing achieves. A series of precision rollers pulls multiple slivers together, stretching them gently as they move forward. The fibers begin mixing with one another. Any small irregularities become evenly distributed throughout the material. Imagine shuffling several decks of cards together. Instead of isolated imperfections, everything becomes balanced. The result is a new sliver that is far more consistent than any single one could ever be on its own. It is another reminder that quality is not created in one dramatic step. It is built through dozens of small improvements. From there, the material enters the spinning frames. This is where loose fibers are transformed into true textile yarn. As the fibers travel through another sequence of rollers, they are drawn even finer, thinner, more delicate, until only a narrow ribbon of aligned fibers remains. Then comes the defining moment. The ribbon begins to rotate, slowly at first, then faster and faster. Thousands of twists are inserted into the fibers every single minute. That twisting action changes everything. Individual fibers that could easily pull apart suddenly lock together. Friction holds them in place. The more precisely they are twisted, the stronger the yarn becomes. It is surprisingly similar to twisting dozens of tiny ropes into one larger cable. Each individual strand may be fragile, but together, they create remarkable strength. Watching the spinning room in operation is mesmerizing. Hundreds of spindles rotate simultaneously, each one producing a continuous thread without interruption. The sound is unlike anywhere else in the factory. A constant mechanical rhythm fills the air, soft, fast, almost hypnotic. Kilometer after kilometer of fine white yarn slowly forms before your eyes. If you did not know its origin, you would assume it came from cotton or some other traditional textile fiber. Nothing about it suggests oranges. The transformation is now complete enough that only laboratory records reveal where the material truly began. But producing yarn is not simply about twisting fibers together. The amount of twist is carefully engineered. Too little and the yarn becomes weak. It may break during weaving or wear out quickly in finished garments. Too much and the yarn becomes stiff. The finished fabric loses its softness, its elegant drape, its luxurious feel. Finding the perfect balance requires years of research. Different fabrics require different yarn characteristics. A lightweight blouse, a luxury scarf, an elegant lining. Each demands its own precise spinning parameters. Even though they are all made from the same orange cellulose, their final performance begins here. As every spool fills, automatic monitoring systems continuously inspect the thread. Laser sensors measure its diameter thousands of times every second. Electronic tension controls ensure every meter is wound with exactly the same force. If even the slightest inconsistency appears, the system reacts immediately. Sometimes the machine adjusts itself automatically. Other times, it stops production altogether, because allowing defective yarn to continue downstream would waste far more time than correcting the problem immediately. In luxury manufacturing, prevention is always more efficient than repair. Once each bobbin is full, robotic handling systems carefully remove it from the spinning frame. Fresh, empty tubes replace the finished ones without interrupting production. The completed bobbins are surprisingly compact, yet each one contains several kilometers of continuous thread, enough to produce countless garments once woven into fabric. Looking across the warehouse, rows upon rows of identical white bobbins stand waiting. At first glance, they appear almost ordinary, but each one represents one of the most unusual supply chains in modern fashion. Every thread began as agricultural waste. Every spool tells the story of materials that were never supposed to become clothing. Before weaving can begin, another round of quality control takes place. Samples from every production batch are tested in specialized laboratories. Machines gently pull the yarn until it breaks. They measure its tensile strength, its elasticity, its resistance to repeated stress, its uniformity over long distances, even its surface smoothness. Luxury brands do not simply buy yarn, they buy predictability. A designer expects one roll to behave exactly like the next. If one batch reacts differently during dyeing, or stretches differently during sewing, entire collections can be affected. That is why every kilometer of thread must meet the same exact standards. Consistency is not just desirable, it is essential. Only after passing every inspection does the yarn move to the weaving department. Here, Hundreds, sometimes thousands, of individual threads are arranged side by side to form the warp. Another set of threads begins weaving over and under them at astonishing speed. Back and forth, again and again. Thousands of perfectly synchronized movements occur every minute. Slowly, what was once nothing more than individual strands begins taking on a completely new identity. For the first time, it actually looks like fabric. A smooth sheet gradually grows across the loom, soft to the touch, elegant under the lights, strong enough to withstand years of use, yet still incredibly lightweight. It is a remarkable moment because standing in front of that loom, you are no longer looking at recycled waste. You are looking at luxury textile. But despite its beautiful appearance, the fabric still is not ready for the world's leading fashion houses. Its final color, its texture, its softness, and its unmistakable premium finish have yet to be created. Because in the next stage, the factory transforms a technically perfect fabric into something that truly feels luxurious. And that is where science finally gives way to craftsmanship. Standing beside the weaving machines, it is hard to believe the journey is almost over. The fabric already looks elegant. Its surface is smooth, its structure is perfectly uniform. And for most industries, it would already be considered finished. But luxury fashion does not settle for good enough. Because what separates an ordinary fabric from a premium one is not always visible. Often, it is something you feel, the way it moves, the way it catches the light, the way it drapes naturally over the body. Creating those qualities requires one final series of transformations. This is where engineering meets craftsmanship. The first destination is the dyeing department. Despite its beautiful appearance, the freshly woven fabric is still almost completely white, a blank canvas. Luxury brands rarely want plain white fabric. Each fashion collection demands its own unique colors. Some require deep, dramatic blacks, others elegant creams, soft earth tones, bold seasonal shades, or colors developed exclusively for a single designer. Before the dyeing process begins, the fabric is thoroughly washed once again. This removes any remaining spinning lubricants or microscopic residues left behind during weaving. Even the smallest contamination could prevent the dye from penetrating evenly. For luxury textiles, an uneven color isn't just a cosmetic flaw. It's enough to reject an entire production batch. Massive dyeing vessels slowly fill with carefully prepared solutions. Unlike household fabrics, these colors aren't chosen by eye. Every formula is calculated to the gram. Temperature, time, water chemistry, and dye concentration are all precisely controlled, because 2 rolls of fabric produced months apart must still match perfectly. Imagine a fashion house ordering additional fabric halfway through producing an entire clothing collection. If the colors don't match exactly, the garments become impossible to sell together. Consistency isn't simply important, it's everything. As the fabric moves gently through the dye baths, the color begins penetrating every individual fiber, not just coating the surface, but becoming part of the textile itself. This gives the material remarkable depth and durability. After dyeing, the fabric passes through multiple rinsing stages. Any excess pigment is carefully removed, until only the color permanently bonded to the cellulose remains. The water leaving these systems is continuously filtered and treated. Many modern textile facilities recycle significant portions of their process water, reducing both waste and environmental impact. It's another example of how today's most advanced factories combine performance with sustainability. Now comes one of the least obvious, but most important, stages of the entire production process: finishing. This is where the fabric begins developing its unique personality. Some customers want an exceptionally smooth surface. Others prefer a softer, more natural touch. Some luxury garments require extra fluidity. Others need slightly more structure. Every characteristic can be adjusted through specialized finishing treatments. The fabric travels through a series of heated rollers that carefully control its thickness and surface texture. This process is known as calendaring. As enormous, polished cylinders press gently against the textile, its surface becomes even smoother. Light begins reflecting more evenly across the fibers. The fabric develops the subtle sheen often associated with premium materials. It is not an artificial shine, it is controlled precision. But appearance is only half the story. Luxury clothing has to move beautifully. Engineers refer to this as drape, the way a fabric naturally falls under its own weight. Too stiff, and a dress loses its elegance. Too soft, and a tailored jacket may lose its shape. Finding the perfect balance requires countless adjustments. Small changes in pressure, temperature, moisture, or finishing speed can completely alter how the fabric behaves. Experienced technicians constantly evaluate samples by hand. They stretch them, fold them, allow them to hang naturally. Because no laboratory instrument can fully replace the human sense of touch, in luxury manufacturing, technology and craftsmanship work side by side. Depending on the final customer, the orange cellulose fabric may also be blended with other premium fibers. Silk can increase its natural luster. Wool may improve warmth. Organic cotton can alter texture, or the fabric may remain entirely composed of regenerated cellulose. Each combination creates its own personality, its own movement, its own purpose. A lightweight summer blouse requires very different characteristics than an elegant evening dress. The versatility of the material allows designers to explore an extraordinary range of possibilities, all beginning with the same discarded orange peel. Before the fabric can leave the factory, it faces its most demanding inspection yet. Powerful illuminated inspection tables slowly unwind every roll. Highly trained specialists examine the surface meter by meter, searching for anything unusual, a tiny weaving defect, a color variation almost impossible to notice, a microscopic knot, a loose thread, an irregular texture. Even imperfections smaller than a grain of rice are carefully recorded. Some sections are removed entirely. Others are repaired by hand using incredibly fine tools. For luxury clients, perfection is not optional, it is expected. At the same time, advanced optical scanners inspect the textile using high-resolution cameras. These systems detect irregularities invisible to the human eye, minute differences in weave density, tiny variations in surface reflection, even microscopic flaws hidden within the structure of the fabric. The combination of human expertise and artificial vision creates an inspection process far more reliable than either could achieve alone. Every roll must pass both. Only then does it earn approval. Finally, the finished fabric is wound onto large precision rolls. Protective coverings shield it from dust, moisture, and sunlight during transport. Each roll receives a detailed identification label, its production date, its batch number, its technical specifications, its complete manufacturing history. From the moment the oranges arrived at the factory, every stage has been documented, every inspection recorded, every quality test preserved. That traceability follows the fabric all the way to the fashion house that will eventually transform it into clothing. At last, the manufacturing process is complete. What began as sticky fruit waste has become an elegant textile worthy of the world's most demanding designers. But the story does not end here, because this fabric still has not become what it was truly created for. Somewhere else, in design studios across Italy, Paris, London, and New York, fashion designers are waiting. They are about to transform these perfectly finished rolls of fabric into garments that will appear on luxury runways, exclusive boutiques, and perhaps even red carpets around the world. And that is where our story reaches its final destination. By the time the final inspection is complete, the transformation is almost impossible to comprehend. What arrived at the factory as thousands of kilograms of sticky orange waste leaves as rolls of luxurious textile, soft, elegant, beautifully engineered. If you were handed a finished piece of the fabric, you would never imagine its extraordinary origin. There is no scent of citrus, no trace of peel, no visible reminder of the fruit that made it possible. Only a premium material, ready to become part of the fashion world. But before that happens, one final journey remains. Inside the shipping warehouse, towering racks hold hundreds of carefully wrapped fabric rolls. Each one has already been assigned to a specific customer. Some are destined for small artisan workshops in Italy. Others will travel to some of the world's most prestigious fashion manufacturers. Every shipment is planned with remarkable precision. Temperature, humidity, packaging, transportation routes, even the way each roll is loaded onto a truck is carefully considered. Luxury textiles can spend weeks traveling across Europe or even across the world. They must arrive in exactly the same condition they left the factory, because for premium fashion brands, perfection does not end at production. It continues all the way to the designer's studio. Every roll carries its own identity, a barcode, a production batch, laboratory results, quality certifications, and a complete manufacturing history. With a simple scan, manufacturers can trace the fabric all the way back through the production process, back through the finishing department, the weaving room, the spinning machines, the lyocell reactors, the cellulose extraction process, and ultimately, to the very oranges that arrived from the juice factories of Sicily. That level of traceability has become increasingly important in modern fashion. Today's consumers want to know where their clothing comes from, how it was made, and what impact it had on the environment. For luxury brands, transparency is becoming just as valuable as craftsmanship. Once the fabric reaches the fashion houses, a completely different kind of creativity begins. Designers study how the material reacts to movement, how it reflects light, how it feels against the skin. Some choose to create flowing dresses that highlight its silky drape. Others use it for elegant blouses, luxury scarves, sophisticated linings, or limited edition collections focused on sustainable innovation. Every designer sees something different, but they all begin with the same remarkable material, a fiber that was never supposed to exist. The journey continues inside ateliers and workshops. Highly skilled pattern makers carefully every panel. Master tailors stitch each garment with incredible precision. Seams are pressed, details are refined, buttons, linings, labels. Every element is assembled with the same attention to detail that defined the manufacturing process from the very beginning. Weeks later, the finished garments leave the workshop. Some are displayed in luxury boutiques. Others appear in seasonal collections presented in Milan, Paris, London, or New York. Many customers who admire these elegant pieces will never realize what they're actually wearing. To them, it is simply a beautiful fabric, soft, lightweight, luxurious. Only a few will discover that the journey began with something as ordinary as discarded orange peels. Perhaps that is the most remarkable part of this entire story. The greatest transformation is not technological. It is philosophical. For generations, industrial waste was seen as the end of a product's life, something to dispose of, something to bury, or something to burn. Today, factories like this are proving that waste can become the beginning of an entirely new industry, not by lowering quality, but by raising it, not by accepting compromise, but by redefining what premium materials can be. It's a powerful reminder that innovation doesn't always come from discovering new resources. Sometimes, it comes from seeing old ones differently. Every year, millions of tons of agricultural byproducts are discarded around the world. Orange peels, coffee husks, pineapple leaves, banana stems. Materials once considered worthless are now inspiring entirely new generations of sustainable textiles. As technology continues to evolve, the factories of tomorrow may rely less on extracting new raw materials and more on unlocking the hidden potential of the resources we already have. The future of manufacturing may not begin in a mine or a forest, but in the leftovers we once ignored. And that's what makes this factory so extraordinary. It doesn't just produce fabric. It transforms an environmental challenge into an engineering achievement. It combines chemistry, materials science, precision manufacturing, and human creativity to prove that luxury and sustainability no longer have to exist on opposite sides of the industry. Every roll of fabric leaving this building tells the same story, a story of innovation, of resourcefulness, and of seeing opportunity where everyone else saw waste. If you enjoyed discovering how ordinary orange waste can be transformed into luxury fabric, you're in the right place. Here on Source Code, we take you inside the world's most fascinating factories, uncover the engineering behind the products we use every day, and reveal the hidden processes that most people never get to see. So if you don't want to miss the next incredible story, make sure to subscribe, turn on notifications, and join us for another journey inside the world's most extraordinary factories. Thanks for watching, and we'll see you in the next episode of Source Code.